Light is a form of energy which gives us a sensation to our sight. So whenever a light falls on any object, it gets reflected and comes to our eyes and we see that object. But in some cases, light passes through that transparent material. So it passes or it bends from one medium to another while passing. Okay. So good morning students, welcome to my next online class. So in this video we are going to start a new chapter, that is light energy, or you can say refraction of light. So in this video we will learn why light gets bent when it moves from one medium to another, what are the laws of refraction, what are refractive index. So watch the video till the end and stay tuned. Light travels in a straight line. This is called a rectilinear propagation of light. But when the same light, when it travels from one transparent to the another transparent medium, it changes its direction and it seems to get bent. So the bending of light when it travels from one medium to another medium, it is called refraction of light. So this refraction of light can be easily understood from this example. You see a pencil is immersed in a water and it appears to get bent. Now when this pencil, you see, when it is viewed from here, then it has been seen that the actual position of pencil is not at y, it is seen at x, right? It seems to get bent, that means the pencil appears to get bent, but actually the original pencil has to be like this, right? So this bending of light when it travels from one medium to another is called refraction of light. That means when you are looking from here, your light is getting bent, right? So as it is getting bent, as light is getting bent, it changes its direction, so this pencil appears to get bent. So it seems to us that it is broken, but actually it is not so. So speed of light in different medium is different. Like speed of light in air, it is 3 into 10 to the power 8 meter per second. In air it is 3 into 10 to the power 8 meter per second. In water it is 2.25 into 10 to the power 8 meter per second, and in glass it is 1.8 into 10 to the power 8 meter per second. So these are the velocity of light in different medium, in air, water and glass. So water is optically denser than air, glass is optically denser than air and water. So in other words, we can say that water is optically rarer than glass, or air is optically rarer than water and glass. Now what does this mean? You see, the speed of light is maximum in air than as compared to water and glass, because their densities are not same. So this bending is taking place due to the density of the medium. If the medium is lighter, then the velocity of light will be more. If the density of the medium is more, so the velocity will be less. So you can see from here what is the speed of light in air, 3 into 10 to the power 8 meter per second. But in case of water it is only 2.25 into 10 to the power 8 meter per second. So which one is more? So 3 into 10 to the power 8 meter per second is more. So because air is lighter, that means less denser as compared to water. So speed of light in air, it is more than the speed of light in water. So in this paragraph you will see that why the bending takes place. This bending takes place because whenever a light moves from one medium to another medium, first of all its density is getting changed. Now as the density is getting changed, its speed also gets changed, because speed is based on densities, or you can say speed depends upon density. So here you can see from the paragraph, when a light has to travel from one medium to another obliquely, from air to water or from air to glass, it has to take a path which requires the shortest time. Since the speed of light is different in different medium, it chooses a path where it travels a greater distance in the medium in which it has a greater speed and less in a medium in which it has a lesser speed. So it bends at the surface of the separation to achieve this. Now what is said here actually, whenever a light, let us consider this is a vessel and this is the water contained in that vessel. So whenever a light travels from air to water, if I consider this one as air and this one as water, right, or you can say H2, I am writing here H2O. So whenever a light moves from air to water, at the surface it gets bent. Now why it is getting bent? Because speed of light in air is more than the speed of light in water. So at the surface it gets bent. Now as it gets bent, as the density is different, it speeds lower down. If the density is more, then speed will be less. If the density will be less, then speed will be more. So as the speed slows down here, so it covers less distance, right? So this appears to get bent. Now some common examples of refraction of light, you see the fruit appears to be bigger in size in glass of water due to refraction. That means in a glass of water, if you place any fruit and from outside when you will view that, you will find that the fruit is bigger in size. This is due to refraction of light. Printed text appears to raised when seen through a glass block placed over it. That means if you place a glass slab on your book and you see from up, you will find that the letters are big in size. Swimming pool appears shallower than its actual depth. A person's legs also appear shorter than the actual length when he or she is standing inside a pool. So these are the examples of refraction of light. So other examples are densities of atmosphere decreases with increase in altitude. That means more height you go, more altitude, more the height, so density will be less. So therefore light rays which comes from star, it comes from different densities of layer of atmosphere. That means it passes different layers of atmosphere, and due to this there is a changing in position or twinkling of stars. This gives a twinkling effect as light is traveling from very far distance and it is passing through different layers, and while passing through different layers, you see the position of the light gets changed. Due to this, it appears to us that it is twinkling in nature, or it produces a twinkling effect. So we see that sun a few minutes before it actually rises above the horizon in the morning. This happens because the rays of light passing through different layers of atmosphere undergo refraction and bend. Hence the viewer sees the sun at the higher position than actually it is. So this is also a example of refraction of light. Here it is said that the sun has not rose, but still few minutes before only you can see that the sun has rose. So this happens because the rays of light passing through different layers of atmosphere undergo refraction and bend. If I consider this is to be earth and this is to be sun, so when you see from here, as different layers of atmospheres are there, so due to these different layers of atmosphere, it appears to us that the sun has came up. Okay, the position of sun appears to us changing. So before few minutes only we see that the sun has already risen. So in your textbook you have seen this, there is a fill in the blanks. So this one you need to solve by yourself. You see the questions are not very tough. A pencil appears to be bent when partially immersed in beaker of water due to refraction of light. Glass is optically rare. Okay, so you see glass is optically denser or rarer than water. You see So in case here, so in the note you see what was the speed of light in glass, that is 1.8 10 to the power 8 meter per second in glass. In water it is 2.25 10 to the power 8 meter per second. So we can say the speed of light in water is more. As the speed of light in water is more, so we say that the density of water is less than the density of glass. Or here we can say that the glass is optically denser. Okay, optically denser than water, so denser is the correct answer. The speed of light in water is 2.25 into 10 to the power 8 meter per second. A swimming pool appears shallower than its actual depth, shallower, right? So this is the correct answer. Now refraction of ray of light, you see, so some related terms are there. Whenever a light falls on a surface and after falling on a surface it gets bent, right? You see this is the bending, and this is called incident ray. So when a incident ray AO falls on an interface, that is EF, that means EF is the air glass interface. So whenever a light falls on any surface, then it gets bent. You see it is bending, but actual path of that light has to be this OC, but it seems to get bent OB, right? So the angle subtended between incident ray and normal is called angle of incidence. This angle is called angle of incidence. It is denoted by angle I. Okay, the angle subtended between refracted ray, that means this ray is called refracted ray, and this angle is called angle of refraction, angle R. So the angle subtended between refracted ray and normal is called angle of refraction. So you see, whenever a light falls on any medium, it gets bent. This bended light OB is called refracted ray and AO is called incident ray, and O is called point of incidence, because at this point incident ray is striking. So from a point of incidence, when a perpendicular line is drawn, that is called normal. So these terms, related terms of refraction, you have to write in your exercise book. You need to draw this diagram and you need to write a definition of incident ray, normal, refracted ray. Okay, so this angle of incidence, angle of refraction. So incident ray you will be writing, it is a ray of light in the first medium which strikes an interface. Okay, so this is the definition of incident ray, but here you need to add a few words. The ray of light in the first medium which strikes the interface. Okay, so after this you will be writing which strikes the interface is called incident ray. Next, refracted ray, the ray of light after changing its direction in the second medium after refraction is called refracted ray. So point of incidence, the point where the incident ray touches the boundary between the two mediums. So this point I was talking about, point of incidence, that means point O is the point of incidence. A perpendicular drawn to the air glass interface at the point of incidence is called normal, or you can say a perpendicular line passing through point of incidence. A perpendicular line passing through point of incidence O is called normal. Angle of incidence, you can say the angle subtended between incident ray and normal. So the angle subtended between incident ray and normal is called angle of incidence. Angle of refraction you can define as the angle subtended between normal and refracted ray, this angle, right? You see this one. So this is called angle of refraction. So these are the different terms you need to write in your exercise book. These are the rules of refraction. Whenever a light is moving from air to glass, it will bend towards the normal. Okay, so if you consider this is the normal and this is the interface, so whenever a light is falling here, it will move towards the normal. such that angle of incidence is always greater than angle of refraction. So whenever a light travels from air to glass, angle of incidence is always greater than angle of refraction. This one you remember. Now similarly, whenever a light moves from glass to air, now you see here it is glass. Now it is moving from denser to rarer, so it will move away from the normal. Or you can say like this, suppose this is water and this is air. Now when light is moving from water to air, so this is the normal, so it will move away from the normal, right? This is angle of incidence and this is angle of refraction. So in this case, angle of incidence is less than angle of refraction. So by looking this, by understanding this, if angle of incidence is less than angle of refraction, so you understand that it is moving from denser to rarer, that means from glass to air. But if angle of incidence is more than angle of refraction, then it is moving from air to glass, that means light is moving from air to glass. Now similarly, when a light falls from air to glass perpendicularly 90 degree, making an angle 90 degree, so there is no bending, that means there is no deviation, light moves straight. You see from this diagram, so light is moving from air and is passing through glass, but normally the line is very straight, so the light will go deep straight, there won't be any bending in this case. So here you see 3 points are given. These 3 points also you need to read very nicely. So angle of refraction when it is less than angle of incidence, that means light is moving from rarer to denser. When angle of refraction is more than the angle of incidence, so that means light is moving from glass to air, or that is from denser to rarer. Okay, whenever a light travels straight passing through two different medium, that means the angle of incidence and angle of refraction is 0 degree. Okay, so these are the important terms in this chapter. Rules of refraction. Principle of reversibility. If I consider this is the interface of air and glass, and light is moving from air to glass, as it is moving from air to glass, this is the normal drawn from point of incidence, so it will move towards the normal. Now if a light is made to move in opposite direction, that is from glass to air, it will pass through same path. That means if light is moving from air to glass, the same path will be followed when it moves from glass to air, right? So this is the path, you see. Okay, this arrow sign is the path. So you see in the definition what is given. Principle of reversibility. So according to principle of reversibility, the path of light is reversed. That is, if the path of light from air to glass is A to O to B, then the path of glass will be from B to O to A. So it will be easily understood from the diagram. If the path of light is from A to O to B, now if you reverse the path, that means from B to O to A, it will pass the same path. That means if you change the arrow, it will go in the same path. This is called reversibility of light. Next we have laws of refraction. So there are two laws. Incident ray normal to the point of incidence and refracted ray all lie in the same plane. And the ratio of sine of angle of incidence to the sine of angle of refraction is constant. This is also called Snell's law. Okay. So these are the two laws of refraction. Now what do you mean by sine of angle of incidence? Sine of angle of incidence means here the angle between the incident ray and a normal, that angle is sinusoidal. So in a higher class you will come to know what is sinusoidal. So short form of sinusoidal is sine. in a small language we can say that, in a simple language, that light travels in this way. So this shape is called sinusoidal. So short form is what? Sine. So that is why we say that sine of angle of incidence to the sine of angle of refraction is constant. This is known as refractive index to the medium, or it is also called as Snell's law. So these are the two laws of refraction. It's very important. Refraction or refractive index here, the ratio of speed of light in air to the speed of light in another medium is called refractive index. So when we need to find the speed of light in any given medium, and if the refractive index is given in the question, then we can easily find the refractive index. So it states that refractive index is denoted by nu. So this sign is called nu. Okay, NEU, nu. So refractive index equals to speed of light in air or vacuum by speed of light in given medium. Okay, given medium, like you can say glass, water, or any other medium apart from air or vacuum. Okay, so vacuum means where there is no any other medium. Okay, so these are the different definitions and different topics. So important topics which we have discussed today here in the video. So you need to write in your exercise book and make a note. So for this video only this much. Thank you. See you in next video very soon.